In question 10a, we are given the first three terms in a sequence of rectangles and must draw the fourth term. The first term has one rectangle, the second has two rectangles, and the third has three rectangles. Continuing the pattern, the fourth term will contain four rectangles. The height of the triangle, which is 8 units, is equally split over the four rectangles, so each one will have a height of 2 units. In B, we must find the total area of the three rectangles in the third term. The triangle is 8 units tall, and this is evenly split among the three rectangles, so each rectangle will have a height of 8 over 3 units. The width of the triangle grows from 0 units at the top to 2 units at the bottom. Since the width grows at a constant rate, the growth in the width over each of the rectangles will be the same, 2 over 3 units. This tells us that the top rectangle has a width of 2 over 3, the middle rectangle has a width of 4 over 3, and the bottom rectangle has a width of 6 over 3, which is equal to 2. Now, we can find the area of each rectangle by multiplying the height by the width. To find our total area, we simply add these results together. In part C, we must find the total area of the n rectangles in Tn. We can do this by generalising the argument from part B. The total height of the triangle, 8 units, is split evenly among the n rectangles, which means each rectangle will have a height of 8 over n. The width of the triangle grows from 0 units at the top to 2 units at the bottom. Since the width increases at a steady rate, the increase of width between successive rectangles will be 2 over n. In other words, the widths of the rectangles will be 2 over n, 4 over n, 6 over n, all the way up to 2n over n. Multiplying each of the rectangle widths by the common rectangle height, 8 over n, gives us the areas of the rectangles. Adding these together gives us the total area. From here, we can factor out the common 8 over n, and then factor out another 1 over n. To calculate the expression inside the brackets, we can use the formula for the sum of an arithmetic sequence. The number of terms, n, is equal to n. The first term, a, is equal to 2. And the common difference, d, is equal to 2. When we sub in and simplify, we get n times 2 plus 2n all over 2. We can write this expression in for the sum we had, and then simplify to get our final answer. In part D, we're given an expression for an and asked to find the first value of n for which an is greater than 95% of the area of our triangle. The area of a triangle is equal to a half times the base times the perpendicular height. For our triangle, this comes out as a half times 2 times 8, which is 8. To find 95% of the area, we multiply 8 by 95%, which gives us 7.6. We need an, which equals 8 times n minus 1 all over n, to be greater than this value. We can solve this inequality to find the value of n. We multiply both sides by n, multiply the brackets on the left, subtract 7.6n from both sides, simplify, and then divide both sides by 0.4. N is an integer, and n must be strictly greater than 20. the smallest value of n which satisfies these conditions is n is equal to 21. In part E, we must find the volume of a pyramid in terms of the constants c and h. We're given an expression for the volume. It's the integral from 0 to h of s of x. So the question simply boils down to calculating this integral. We're told that s of x is equal to x squared times c squared over h squared. C and h are both constants, so the multiplicative constant, c squared over h squared, can be brought outside the integral sign. X squared integrates to x cubed over 3. We sub in the upper limit, h, sub in the lower limit, 0, and then subtract. We simplify, and then observe that h cubed divided by h squared is equal to h. This brings us to our final answer. In EII, we must find the rate of change of s with respect to time when x is half the perpendicular height of the pyramid. In terms of derivatives, this corresponds to evaluating ds dt at x equal to h over 2. We can solve this using related rates. The derivative we want, ds dt, can be written as the product of ds dx and dx dt. We are told that x increases at a rate of 3 units per second, so the rate of change, dx dt, is equal to 3. S of x was defined to be x squared times c squared over h squared. Differentiating this expression and simplifying tells us that ds dx is 2xc squared over h squared. ds dt is the product of these two derivatives, which comes out as 6xc squared over h squared. We want the rate of change when x is half the perpendicular height of the pyramid, so we should sub in x equals h over 2. Cancelling the h in the numerator with one of the h's in the denominator brings us to our final answer of 3c squared over h square units per second.